All right. Welcome everybody to Cassandra Lunch 29. We have been going at this for a while now. We started this in the pandemic because all meetups have become virtual. And now it's no longer a special session. We're planning on doing this for good. So every Wednesday at noon, 11 Central, we talk about Cassandra. Today, we're going to actually just talk about a couple of updates in the Cassandra and Kubernetes community that took place last week after KubeCon. Some updates from various players in the Cassandra community, including Orange Telecom, DataStax, and there's a new project out that we'll talk about that could be useful for you. Akwi and I are co-organizers. Akwi is responsible for helping produce the blog posts and the videos that eventually get out there on YouTube. So thanks, Akwi, for your work. And we're always looking for other helpers to help, either execute on production of these webinars and putting them up, helping get more people, speakers, sponsors, etc. We are part of a much bigger data community DC. We're a diverse group, always looking for people from different backgrounds to come talk about data. We're part of a group of 12, including us, meetups. We cover Cassandra, Cassandra compliant data stores, and anything that talks to Cassandra, which is a lot of stuff, actually, including, for example, things like Amazon key spaces for Cassandra, which is a Cassandra compliant database managed by Amazon, but it's not Cassandra. Or Cosmos DB with Cassandra API. Similarly, again, it's not Cassandra, but it's accessible using the Cassandra query language. And we talk about other things as well, like Kafka, Spark, as long as it works with Cassandra. Anybody that is new want to say hi? I believe we have a few new people. I see Nirmal. I know you were on the data engineering lunch, but maybe just introduce yourself. This is a different group in terms of audience. What your experience is with Cassandra, what you've done with it, or what you want to learn.
Hi, everybody. So thank you, Rahul. So my name is Nirmal. I'm a budding data engineer. My title is a senior data engineer at my employer, one of my employers at Capital One. But it's been only about 2.5 years that I've been doing core engineering. And I'm excited to be here and join hands to learn because this fits very well with my agenda and goal for this year and next year. So far I've done data engineering only using AWS technologies, and obviously, the shell script and whatnot is Scala, Java. Cassandra is very interesting to me. It was because of Rahul that he lent me a book that I started to delve into it, and got more interested. But it makes a lot of sense everywhere. I have worked. I have seen they had database for transactional purposes, and then they had a data store for analytical purposes. Whereas Cassandra sort of combines all those needs in one. So that's very interesting. It's like groundbreaking technology for me. My only goal is to get more hands-on on it, help out in any way possible, like you were explaining earlier, help out with a blog post or a video, things like that. So I'll be interested in doing some help there as well. But yeah, by trade, by education, I'm a computer science grad with a major focus on Java, Scala. Well, recently I've been doing a lot of Python as well, but I've been in the field about 10 years or so. But yeah, what else? Yeah, just today I got a 1,000 points on my Stack Overflow, so I answer questions there, and I got.
Congratulations!
Thank you. So it's like unless you're 1,000, your number shows like whatever number, but now it'll show like in K, so 1K or like that. I also got a gold medal for being active and stuff. So it's interesting to kind of go out there and
Help out.
yeah, help out. And also there's an app, so it's stuff that I'm interested in. So recently I added Cassandra as well. So anybody in the world who asks questions about Cassandra, it just gives a pop-up on my phone. Most of the time I don't
Cool.
really look, but it is out there. It's just like a reminder on my head. But yeah, that's too much about me. Thank you very much. Yep.
Thanks, Nirmal. There's also John with a capital JOHN. If you want to introduce yourself.
Hi, John in the 3WC office, Washington. I got the invite, thought I would come check it out, see what I can learn.
Cool. Awesome. Thanks, John. All right. General group rules. If you have a question, just ask it in the chat. Basically, it's an opportunity for you to share something as well as ask a question. It's not necessarily just one way. DataStax is a sponsor and a partner, so is GW. We have some local sponsors as well as some institutional sponsors. Any announcements that we can mention? Well, we do have some. One, so you can always go Google Cassandra Lunch on YouTube or on Google, excuse me, and find previous recordings. We also have Cassandra.Link, which is the world's best knowledge base on Apache Cassandra, always adding new knowledge, and it gets published on a daily basis. After we curate content, it gets published at 5 a.m. We have we had an event yesterday related to running a Spark job on DataStax Astra, and we have another one coming up next week on how to do counting in DataStax Enterprise. I'm curious about that as well. We have this weekly, and DataStax also has weekly workshops. If you were curious about learning different aspects of DataStax has lots of amazing resources, including Kata Coda interactive demos, hands-on demos where you don't have to install anything. They give you a container to go play around with. And a lot of their workshops are similar. And then we're actually doing another workshop related to Spark and Cassandra and Kafka in a few weeks. So we'll keep you posted with the new date. All right. Today, I wanted to give you guys an update on Kubernetes and Cassandra. We did an update. One of the first topics we talked about before we were actually writing blog posts about everything was on Cassandra and Kubernetes. And then people had requested like another update on Cassandra and Kubernetes. So last week there were a few different big news items that came up in the industry, and I wanted to talk you through so you guys are aware. Number one, the most important thing is that Orange Telecom's, which was one of the first Cassandra operators. There's about 5 or 6 of them, by the way. But Orange Telecom is a part of the special interest group for Cassandra and Kubernetes, and they have decided to basically merge in their changes that are their features into Cass operator, which is made by DataStax, which is one of the other ones. As I said, there's 5 or 6. There's one by InstaCluster. There's one by Cassandra. There's a few of them out there. And basically, the features that are going to get merged into the Cass operator are useful. But here's a list from Cyril, who's one of the main contributors to CassKop at Orange Telecom. He basically mentioned, these are the first set of features that are going to get merged into the Cass operator. So one is labeling nodes. So when you label a node, it basically allows you to place that node in a particular data center or a rack. Support for volumes and sidecars. Basically being able to add data volumes, config volumes. Sidecars are basically services that run beside Cassandra to help manage Cassandra. Backup and restore, they have a built-in method using the Insta cluster. I think it's like ESOP or one of their Insta clusters ecosystem of Kubernetes tools. And Medusa is another one that works with any Cassandra, not necessarily just with Kubernetes. So they ended up using the Insta cluster implementation. One second. kubectl plugin basically makes a lot easier to operate Cassandra clusters with certain operations. And I think the last feature is really about making CassKop operator, multi-CassKop operator, to be able to manage not just CassKop clusters, but also Cass operator clusters. And I know it's a little bit confusing. That's why it's always good to know who made them. So Orange Telecom made the CassKop one, DataStax made the Cass operator. The Cass operator has a lot of other really cool features. And, instead of the community trying to come up with, I actually wrote the blog post on it on Cassandra.Apache.org. Instead of the community trying to find the best of all the different ones and merge them in, the decision was they're just going to use Cass operator as the base and then have everybody kind of merge in what are the benefits of the other ones into it. Because it's definitely one of the most robust ones, and it's also supported by DataStax. A couple of things that are, well, more than a couple of things. A lot of things that are in the Cass operator that are useful is being able to provision data centers, have certain configurations for seeds across racks, across data centers, being able to add and remove nodes and have it scale up and scale down as needed. We have things like, how to recover nodes, if you have to replace a node, or, if you lose a node, where to get the data and bring it back. Being able to do multi-DC, multi-rack is a part of Cassandra. Being able to do that in Cassandra in Kubernetes is very important. Some of the initial operators for Cassandra were just single DC because it was hard to kind of get it to work in the first place. And then there is ability to do multi-region as well, but it requires a lot of work with networking tools to make it really work. And then doing a multi-Cassandra cluster, multi-Kubernetes cluster, what that means is you have two different Kubernetes clusters, and then having a Cassandra cluster span those two different Kubernetes clusters on two different clouds potentially. That is the promise of Cassandra, to be able to do that. So this is kind of the bare minimum, what the goals are. In terms of differentiators, in relationship to the other operators, they've taken out stuff that's built inside like the operations center of DataStax, and they've open sourced that project, right? This Cass config builder. And Lifecycle Manager was also part of Op Center, and it provides a way to merge configuration changes at the global, the data center, at the node level, and push them out. So that's amazing that it gets kind of put in there. This is huge. I love Lifecycle Manager. I love Op Center. So having something basically take care of, configuration management that's robust, it's amazing. Other differentiators are that management API for Apache Cassandra and metric collector for Apache Cassandra were both open source by DataStax. That's also part of this operator, meaning that out of the box you get some robust ways to get data. They also reference Prometheus and Grafana operators. Prometheus is basically a data store to store metrics data, and then Grafana is a generic data visualizer, similar to Grafana, but really around metrics, more specifically numbers in time series. And if you weren't using this operator, we would, if you Google Cassandra Toolkit, we recommend the same thing. You should use these tools. There's a way to specify your pod and customize it for any particular containers or volumes you want on your pod beyond the recommended ones. And then there's advanced networking, so you can change the port for the node or change the host network. This is what I was saying. I had some nightmares with formatting, and instead of solving it, I'm just going to kind of as I walk through it, I'll fix it. Basic security in place for for SSL, internode, client to node. That's important. Automatic generation of key store, trust store. Like if you've not done this, you don't know how much of a pain it is. And if you use Lifecycle Manager with Op Center, it does it for you. But if you ever had to do this manually, this is a pain in the neck. So to have a secure cluster that's communicating over SSL out of the box, it's amazing. This is kind of like basic admin stuff, right? Making a super user that's separate from Cassandra, and then using a different user to get into it. And then the reason why we do this is that this is the easiest way to hack a Cassandra cluster. Is that people don't know, but people know that Cassandra is the default username and password. But Cassandra as a user, super user, is the most powerful, database user. So what you generally do is you disable and you add other super users to do certain things. That's great that it's kind of part of it. These are, again, related to best practices in Cassandra, basically applying network topology strategy instead of simple strategy. And you have to have the appropriate, replication factor for key spaces there. I have to go deeper into this webhook, but basically what I understand is that when changes are put into Cassandra, if there's any issues, it will ping that webhook and say, hey, some issues are there in your configuration, you need to fix it. And with Kubernetes, it's not going to run a node that has bad configuration or a cluster that has bad configuration. It'll just keep running the old cluster, and then it'll reject the change. Part and parcel with any distributed system, sometimes you have to do a rolling update, meaning you don't want all the nodes to be down at once. Some of the common changes are upgrade Cassandra binaries. There's a change that we need to make. Do a canary deployment of a single rack to see if this works with this particular upgrade or configuration. And then if it works, we can say go ahead and deploy it to the rest of the data center or to the rest of the cluster. Rolling restarts, obviously, because you normally don't just push the binary and it automatically starts. You have to do a rolling restart. Generally, again, after you have a cluster up and running, you have to do some basic, platform integration and testing and certification of it. Some of the things that we look to is, I don't think there's not in this list, but we'll come back. Let's see. Yeah, here we go. So Red Hat has kind of a basic, testing and scanning of the images, and making sure that these containers are essentially, legit. It's also available in the marketplace inside Red Hat. So Red Hat has a huge ecosystem for Kubernetes stuff, right? So the fact that it's available in Red Hat means that it's awesome. VMware has its own Kubernetes thing. Everybody has their own Kubernetes thing, right? So VMware has its own, so it's compatible and certified there. And they do the same type of thing. They scan the images and make sure that they're good. And then the following clouds, are tested, which is most people, they care about Amazon, Google, and Azure. At least that's the ones that I care about. And if you're using Kubernetes beyond these, more than likely it'll still work because Kubernetes is Kubernetes. Right? These are just different distributions of Kubernetes. It's like Linux. Most Linux is basically the same. And there's more I can go into, but like the roadmap, I think we're going to cover later because it's not done yet. But there's pretty good documentation, and I'm going to show you the reference implementation in a second. Different types of storage classes for cloud storage are supported. Ingress solution basically is, if you think about Cassandra, it uses the token range to distribute data. And so one of the benefits of that is that if your driver is aware of the network, aware of the cluster topology, then it can directly talk to the node specifically that it needs to talk to, right? Why is that important? Well, because normally in Kubernetes, when you start up a service that scales automatically, it gets a load balancer. And a load balancer doesn't make sense in the world of Cassandra. So you have to have what we call an ingress solution to properly give each node its own service, quote unquote, service endpoint. And if you don't do that, then you don't get the benefit of Cassandra, the scale of Cassandra, meaning each node can be talking to, each client can be talking to a different node, and that's the only node that it needs to talk to. It doesn't need to talk to anything else. In terms of general operations, this is an important feature. Basically, stop running instances while keeping persistent storage. This is huge because, if we're want to come back tomorrow, we're doing some experimentation, everything works, we want to turn off the cluster, we can keep all of our data and just shut off the nodes that are responsible for the pods. This is huge for not only for basic experimentation, but also for bringing clusters back from the dead, right? Like if a thing just completely stops, if your persistent storage is properly managed, you can bring it back in whole. All right, talking about a lot of stuff. I'm not going to go into the roadmap because these things are not real yet. The other major news is Cassandra. Cassandra is amazing because it's basically taking the Cass operator and taking the best practices for Cassandra on Kubernetes and making a Helm chart out of it. And if you don't know what a Helm chart is like the quick and dirty way to basically get a new system in Kubernetes up and running. People have Helm charts for all different types of combinations of containers. But in Cassandra, what we start off with is, let's see how long this thing takes. I think this is pretty quick. Basically, this is a demo of Cassandra, right? You update your repo, you install the Helm chart. You say, I want a new cluster. There's your cluster. 3 steps. and then once it's up and running, you know, you're able to do whatever Cassandra commands you need to do on it. So highly recommend you guys take a look at Cassandra. Here are the features for Cassandra. Basically, it's not on this page. I was just looking at it. There we go. So the operator, Cass operator, has a lot of the references, you know, for all this. What this does is go beyond that. It uses Reaper for repairs as well, and not sure. I think it also has Medusa for backup. There's a architecture. Oh yeah, that's what I wanted to show. Here we go. So basically, Case operator has everything that you need here. It has Grafana, Prometheus. It has Reaper for repair. It has Stargate for a data API gateway. I will actually go do a deep dive in Stargate later. It's another point. It manages all the Cassandra clusters, and it manages the backups onto, you know, Google Compute Storage or S3 or MinIO, which is a S3 compliant data store. So, you know, why would you go deeper? Why wouldn't you go deeper into trying to do, you know, Cass operator or with like CassKop? Is that it assumes you already know Kubernetes really, really well. It already assumes that you know Cassandra really well, whereas Cassandra does not assume that. It assumes that you just know enough of, you know, Kubernetes, and you know just enough of Cassandra, and it gives you the best scenario, right? So that it's already using the best practices. And I mean, I know this stuff, and I'm like, this is even better. Why should I have to deal with low-level Kubernetes stuff if something can take care of this at a higher level for me? So I'm really excited about Cassandra because it's like the end-user-friendly version of Cassandra and Kubernetes, whereas things like Cass operator and CassKop are for the advanced users to do exactly what they want and customize it to do what they want. This is like ready to go. Some of the ideas that I have for this are, you know, add other applications that, like Spark, for example, right? If you go Google Spark Helm chart, you'll get several of them out there. But here's one that's kind of the main one. And what does the Helm chart do? Helm chart will deploy a general cluster with Zeppelin, which is a notebook, right? So what would be interesting is to deploy Cassandra with Spark, right? And that gives you 2/3 of the way to Offcenter, because to DataStax. DataStax has Spark, it has Cassandra, it has Solar and Graph, so maybe halfway there. So it's interesting what the Helm chart gives you. It gives you the ability to merge other ideas, like, or if you wanted to do the Kafka Helm chart and take aspects of the Kafka Helm chart and put it into your Cassandra Helm chart. You don't have to set up different machines. You have one Kubernetes cluster, and you can have a Helm chart for Cassandra. You can have a Helm chart for Spark. You can have a Helm chart for Kafka, or you can just have one special Helm chart which has everything that you need in your data platform solution. So, yeah, super excited about this because it's going to change Cassandra. And I think the vision that we have in the community is that we want Cassandra to become the default data store that people think about in Kubernetes, because Kubernetes is meant to scale, Cassandra is meant to scale, and you know, doing like MySQL on Kubernetes or Postgres on Kubernetes or even Redis on Kubernetes. These services are monolithic databases, and the only way they scale in Kubernetes is by having a full replica of the data on each node, and then by putting a load balancer in front of it. That's not distributed computing. Cassandra, on the other hand, it was built for cloud native before cloud was actually cloud native was an idea. right? It's literally supposed to scale. That's in the design of the system. It's supposed to scale. So in that, going towards that vision, the community is coming together. DataStax is putting a lot of effort into it. Other organizations like Orange Telecom is putting a lot of effort into it. And the big thing beyond what we have right now, not just the improvements of the operator, is that Cassandra 4.0 is a much more efficient Cassandra. It has a much better streaming engine. It has a much better way to do repairs, and you know, it can start up a node faster and bootstrap it in much faster than before. And if you combine the best of what Cassandra 4.0 has to offer and what these developments in the Kubernetes and Cassandra community have to offer, then we're getting closer to this idea of having a very elastic data store that can scale up and scale down very, very quickly. This is one of the biggest pain points that people complain about Cassandra is, I can't expand and contract the cluster like I thought I could. You can, it just takes time. If you have a lot of data in one node, it has to stream out and stream back in. But if you have Kubernetes, and if you have these operators that are doing the management of creating and destroying nodes, it's all automated, then you can have nodes that have like just, let's say, 500 gigabytes of data, or 100 gigabytes of data, or 50 gigabytes of data. And it's all spread around, you know, instead of having 10 nodes with 1 terabyte each, you have 100 nodes, right? With 100 gigabytes each. And you can expand and contract that cluster much more easily because the data is going to be streamed in and streamed out much more easily. That's what you get with technologies like Dynamo or Cosmos DB. That's what they're doing. Under the hood, they just have smaller pods or containers storing the data, so they can scale out and scale back in much more easily. They also, like Bigtable, for example, they also use a very permanent disk storage. Even though the containers come and go, they own a very permanent disk storage, so that when you scale up and scale down, the disk storage is already scaled. So when you combine Kubernetes, Cassandra, and using very, very permanent, strong, like EBS, for example, on Amazon, you know, you have the disks there. Data is all there. You can expand and contract just like you can on Bigtable. So I think this is going to give the cloud native data providers a run for their money. And it opens up the data, right? If you put data into Bigtable, if you put data into Dynamo, you can only use those services. You can't go to another service. Actually, I lied. There are Dynamo compliant APIs for ScalaDB and also for Cassandra, but you have to install it. But at the end of the day, if you can have your own data store that has the same scale and speed as a cloud native data store, and you can have that data store on multiple clouds like Amazon and Google and Azure, and it's your data store, why wouldn't you use that versus the other one? Well, the answer is that it's a pain in the neck to maintain. And this stuff is going to make that easier. So that's kind of the current, you know, state of Cassandra and Kubernetes. More to come. I am writing another blog post for the Cassandra Apache community, which basically talks about all of this. And that's why I was kind of cleaning up the outline. So when it's done, you'll have an update on our blog, but you'll also see it on the Cassandra.apache.org website. We talked about a bunch of stuff. I'm going to stop talking and see if there's any questions. All right. No questions? Then, you know, we can actually call it a day and wrap up a little bit earlier. Just a quick review back of what we covered today. So we talked about the Cass operator, which is the main community, you know, Cassandra operator now. That's the main one that people are going to be working on. And we talked about CassKop, which is going to donate its features into Cass operator. And so you can see the progress. The items that are getting merged into the Cass operator are put in as issues. And you can actually do a search for, where is the search? Here we go. I think it's like CassKop. That's where it is. Yeah, so these are the things that are going to get put into Cass operator from CassKop. If you're curious, you can download both the Cass operator and play with it. This is how you use the Cass operator. And, you have to kind of go in and set up your cluster config and all that. Or you can go to Cassandra and do the 3 lines to basically run Cassandra. Okay, awesome. Well, thanks everybody for joining. We'll be back next week, same time, same place, noon Eastern, 11 Central, for Cassandra Lunch. Don't forget to subscribe to the YouTube channel and on the Cassandra.Link website for any updates. Thanks, everybody. Talk to you guys soon.
Thank you, everybody. Happy holidays.
Yep. Happy Thanksgiving. Bye-bye.
Happy Thanksgiving, everybody.
Happy Thanksgiving.